So we're going to finish up our chapter 1.6 today. So yesterday we were just talking about how to classify polygons, how to name these polygons. So today we're going to throw in some algebra. So whenever we talk about regular polygons, the key thing here is that all sides are equal and all angles are equal. So when I throw in these algebraic expressions, you're not adding them to a total, you're going to set them equal to each other, because we know that the sides have to be equal and angles have to be equal. So I'm on the 4th page here, example 3, part A. It says each figure is a regular polygon. So again, equal sides, equal angles. Expressions are given for two side lengths. We want to find the value of x. So the nice thing here is I'm just finding x. I don't need to plug this back in. So x squared plus x is one side and x squared plus 4 is the other side. So I'm just going to go ahead and set these equal to each other. Don't let those x squareds daunt you here. If I want to get everything over to one side, when I subtract x squared from both sides, actually it's just gone. And I'm left with x equals 4. Since I don't have to plug it back in, I'm done. Part B, I have a hexagon here. And it says that one side is equal to x squared plus x plus 2, and the other side is equal to x squared plus 3x. So I want all my numbers on one side, all my x's on the other side. I'm going to subtract x squared from both sides, so it's gone. Then I'm going to subtract 3x from both, actually, let's do this a little easier. Let's subtract 2 from both sides. You know what, I'm being silly. Let me just rewrite this. Sorry, you can do it both ways, but really I should have this x squared plus 3x equals x squared plus x plus 2, because this will be nicer. So when I subtract x squared from both sides, it's just gone. And now when I subtract x from both sides, I'm left with 2x equals 2. Divide by 2 on both sides, and I'll get x equals 1. Sorry, I have some compulsive thing where I like the x to be on the left. Part C, again, I have these two sides. This is a 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a nonagon, that one that I really like to say the name of. So I'm going to set my sides equal to each other, because again, for all regular polygons, it's as simple as setting sides or angles equal to one another. So now when I solve for x, when I subtract x squared from both sides, it's just gone. Here I'm going to add x to both sides. So I have 3x plus 40 equals 190. Subtract 40 from both sides. So I get 3x equals 150. Divide both sides by 3. So I get x equals 50. Again, I don't need to plug this back in because this just asked for me to solve for x. So that's just setting side lengths equal. And part of your practice is where you just solve for x. The other part of your practice is where you're going to solve for x and then you're going to plug it back in. So example 4 says that a table is shaped like a regular hexagon. The expressions shown represent side lengths of the hexagonal table. We want to actually find the side length. So I have these two side lengths here, 3x plus 6 and 4x minus 2. So I'm going to set those equal to each other. And then I'm going to get my x on the left and my numbers on the right. So I'll add 2 to both sides. Subtract 3x from both sides. So I get x equals 8. Okay, now I'm not done. I want to find a side length. So I can plug this into either of these equations. Oops, sorry. I'm going to go ahead and just plug this into this equation here. So it would be 3 times 8 plus 6. So that would be equal to 30. And then my units are inches, so it would be that each side is 30 inches. And then remember, if this asked for the perimeter, I would have 30, and then I would be adding 30 plus 30 plus 30 plus 30 plus 30 plus 30, so 6 times 30. But this just asked for one side. And then remember also, it's true that angles are equal for a regular polygon. So this says the expression 8x and 9x minus 15 degrees represent the measures of two angles in the table. We want to find the measure of n angles, so one of our angles. So again, you just set these equal to each other and solve for x. So I'm going to add 15 to both sides. So I have 9x equals 8x plus 15. Subtract 8x from both sides. So I end up with x equals 15. And again, I'm not done. I need to plug this in. So I'm just going to plug it into this one because it's a little easier. So it'd be 8 times 15. So each interior angle is 120 degrees. So each angle is 120 degrees. So this is what your practice today looks like. If you have any questions, make sure you let me know. You can send me an email or send me a message on GoFormative.